In this video, we're going to look at topic 84, example 1, identify inverse variation. The question, how do you determine if a relationship represents an inverse variation? Part A, does the table of values represent an inverse variation? We're giving x and y values. We have 1, 2, 3, 4, 6, 12, and then 12, 6, 4, 3, 2, 1. So this is what you want to focus on here. An inverse variation is a relation between two variables such as one variable increases, the other decreases, and it has to be proportionally. So proportionally is a key word there. One variable has to increase, could be x, could be y, the other has to decrease. For the table to represent an inverse variation, the product of x and y, so product, we're talking multiplication, must be constant. Find the product xy for each column in the table. So we're going to go back and I'm just going to copy the x values, so 1, 2, 3, 4, 6, and 12, and the y values 12, 6, 4, 3, 2, 1. If you notice, these are just the same numbers in reverse. That generally doesn't happen, but for this problem it does. So to see if it's inverse variation, you're going to multiply x times y. So you do 1 times 12, which is 12. 2 times 6, 3 times 4, 4 times 3, 6 times 2, and 12 times 1. Notice that all of them here all come out to be 12. They're all the same. So if the xy, right, the product is constant, this statement here, then you do have inverse variation. So the question, does the table represent an inverse variation? We would say yes. You do need to do every single column to make sure that they're all 12. If the first 5 were 12 and then this one was, say, 13 or any other number, it would not be inverse variation. All right? Every single one has to be exactly the same. So let's take a look at part B. Does the table of values represent an inverse variation? We're going to do the same thing. So we're going to do x times y. 1 times 20 is 20. 2 times 17 is 34. Those two are not the same number, so does this represent inverse variation? No. Once two of them do not match, you can stop. There's really no reason to continue going. If there's two that are different, then it's definitely not inverse variation. For a yes answer, you do have to do every single column and make sure that they all check out. For a no answer, once two of them are different, you can stop doing work. All right, that's it. That's how you find or identify inverse variation using a table or a chart.